Next, let's discuss the resonance between a coil and a capacitor. We take the parasitic resistance of the coil into consideration. Firstly, we draw its phasor graph. We define the port voltage as the reference phasor. For the coil, its current must lag the voltage. For the capacitor, its voltage leads voltage 90 degrees. The modulus of the capacitor current is limited in resonance condition. The voltage and the current of the port are in phase. For the coil, U1 and I1 are in phase, and U2 leads I1 90 degrees. According to KVL, the modulus of U1 and U2 are limited. That is, U1 is vertical to U2, and the sum of the two phasors should equal U. In this circuit, the current triangle and the voltage triangle are both right triangles. They are similar. Next, let's derive the condition of the resonance. This is a parallel connection of a coil and a capacitor, and the input admittance of the circuit is this. The form of the real and the imaginary part is this. The port should represent the characteristic of the resistor in resonance, so the imaginary part should be zero. We can get the resonance condition. You can find that this condition is different from that of the RLC serial resonance and the GCL parallel resonance. The resonance between a coil and a capacitor must satisfy this condition. But we have introduced that the parasitic resistance of the coil is often very small, so the condition isn't hard to be satisfied. By substituting this expression into the real part, we can get the input impedance in resonance. This is a relatively simple conclusion. Next, let's compare the GCL parallel resonance and the resonance between a coil and a capacitor. For the GCL parallel resonance, the angular frequency should satisfy this. The input impedance is this. The effective value of the capacitor's current is this. For the parallel connection of a coil and a capacitor, we can draw its phasor graph. We can get the resonant angular frequency and the input impedance in resonance. Now we will derive the capacitor's current in resonance. According to the input impedance, we can get the port voltage in resonance. Then we can calculate the capacitor's current I2. By substituting the expression of the angular frequency and the voltage, we can get this. So the effective value of the capacitor's current in resonance is this. We need to point out that G is a parasitic parameter of the capacitor in GCL parallel resonance, and R is a parasitic parameter of the inductor here. Let's compare the conclusion of the two parallel resonance. Firstly, the parasitic resistance tends to be zero in the coil and the capacitor parallel resonance. The resonance frequency of the two circuits are the same. Secondly, if the parasitic conductance of the capacitor and the parasitic resistance of the inductor both tend to be zero, then the two input impedance of the two circuits in parallel resonance are both infinite. Similarly, if G tends to be 0 and R tends to be 0, IC in the two resonance circuits both tends to be infinite. Well, this is the end of this lecture.